let's go to page 155 and let's do number 189. So this is the problem. So two altitudes of a scaling triangle. Scaling means all three sides are different. Okay, so let's go and draw a triangle. Okay, and just call it A, B, C. So this is A, B, C. Okay, so two altitudes are given. So altitude is perpendicular to opposite side. So that's 1, and this one is given. So this one is 4, and this one is 12. So the third one would be right over here. I'm going to use different color. Okay, so that's what we're looking for, H. Okay. So it's an integer, and so what is the biggest it can be? Okay, since you don't know if this is the longest or the shortest, okay, so we have to consider 3 cases. Okay, and I'm going to use K for area. Okay, so K equal the area equal to 1/2. I'm going to use this side as a base. Okay, so 1/2 base times the height. So 1/2 base times the height, and the other way would be 1/2 base. So 1/2 base times the height, and also equal to 1/2 the base times the height. Okay. So I'm going to solve for A. So A will equal to 2k over 12. Or if you solve for B, would be equal to 2k over h. Over here, this C will equal to 2k over 4. Okay. And so again, you got 3 cases you have to consider. Well, for again using the inequality, so A had to be less than B plus C. Okay. So I'm going to just, so once we got A, B, C, okay, so that's going to consider 3 cases. So A is less than B plus C, so substituting in here. So 2k over 12. Well, actually, you can simplify. Okay, let's simplify later. So less than B is 2k over h, plus C would be 2k over 4. Okay, and we can get rid of all the 2k's, dividing by 2k. So we got 1 over 12 is less than 1 over h plus 1 over 4. Okay, and multiply everything by, I'm going to multiply everything by 12h. So this would cancel. So h is less than 12 plus 3h. And so from here, go ahead and move, so minus 3h, minus 3h. Okay, so I get negative 2h is less than 12, divided by negative 2, divided by negative 2. So h had to be greater than negative 6. Okay, so this one does not help. Okay, then let's go and do the B. So B had to be less than A plus C. So I'm going to simplify this, make this k over 6, simplify a little bit, and this equal to, so C equal to k over 2. Okay, so simplify things a little bit. Okay, so B is 2k over h is less than k over 6 plus k over 2. Okay, first let's get rid of all the k, dividing by k, and I'm multiplying to get rid of the common denominator, get rid of fraction, multiply by 6h. So 12 is less than h plus 3h. So 12 is less than 4h, divided by 4, divided by 4. So h had to be greater than 3. Okay. Okay, so next one is c had to be less than a plus b. So substitute. So k over 2 had to be less than k over 6 plus 2k over h. So get rid of the k. Dividing by k, then multiplying by 6h. So you got 3h had to be less than h plus 12. So minus h. So 2h had to be less than 12. Divide by 2, divide by 2. So h had to be less than 6. Okay? And so the biggest number would be h equal to 5. Okay, because it has to be less than 6, right? And it's an integer. Okay. Okay, let's go to 190. Okay, you have a right triangle and 2 medians are drawn, and you're looking for the length of a hypotenuse. Okay, you have the right triangle, so this is A, B, C, and you have 2 medians. Okay, so this median is 5 and this is square root of 40. Okay. And so you're looking for hypotenuse. Okay, so for this problem, what you want to do is go and call this D and call this E. And call this Y, because this is the midpoint. So you get Y and you're going to get Z and Z. Okay, so now go and use Pythagorean Theorem. So triangle ACE. So ACE. So you're going to get the 2y squared plus z squared equal to 5 squared. So that's this triangle over here. Now for triangle BCD, so you want to get this triangle, right? So BCD, you're going to get the y squared plus 2z squared. So now this is 2y and this is 2z out here. And this will equal to square root of 40 squared. Okay, so now you can just kind of work out the math. So you got 4y squared plus z squared equal to 25. This one you got y squared plus 4z squared equal to 40. Now you don't want to solve each one individually. What you want to do is you want to use a symmetry. Notice you got 4, 1, 1, 4, right? So if you put this equation down here, you got 4y squared plus z squared equal to 25, and when you add, you're going to get 5y squared plus 5z squared equal to 65. Then after that, I'm going to divide it by 5. So I get y squared plus z squared equal to 13. Okay, but what are we looking for? Well, if you look over here, right, this hypotenuse is equal to what? Equal to this square plus this square equal to that. So in other words, okay, 2y squared plus 2z squared will equal to the x squared, right? Pythagorean theorem for the whole big triangle. Okay, let's go and move down here. Let's go and use it down here. So for triangle ABC, okay, for triangle ABC, we're gonna have 2y squared plus 2z squared equal to x squared. So that's what we're looking for, right? So we need to get 4y squared plus 4z squared equal to x squared. Okay, so but we have 5. So to get from 5 to 4, we divide by 5, and we're going to multiply by 4. Okay, so I got 4y squared plus 4z squared equal to 52. So once I get this, I can substitute into here, right? So I can substitute this into here. So I got 52 equal to x squared. Take the square root. So x will equal to, if you simplify that, you're going to get 2 square root of 13. Okay. So again, this is what you're looking for, but you don't want to solve for y and z individually. Use a symmetry, okay, and you can get that. So pretty good technique. So kind of it shows up quite often in it shows up in the computation. Just be aware of that. Okay, let's go to number 191. Okay, you got tangent of x equal to 2ab over a squared minus b squared. Okay, and you're looking for sine x. Okay, well, if you draw your triangle, so tangent equal to sine over cosine, so this would be 2ab sine over cosine be a squared minus b squared. So sine x would be just this over this. Okay, so but what is this over here? Well, you can use the Pythagorean Theorem, right? Okay, so the hypotenuse equal to square root of this side square plus the second side square, right? Okay, so square plus square equal to the hypotenuse square, and you take the square root. Okay, so hypotenuse equal to square root of, if you work this out, you're going to get a to the 4 plus b to the 4 plus minus 2a squared b squared plus 4a squared b squared. So hypotenuse will equal to square root of, this kind of not too bad. So you got a to the 4 minus 2 plus 4 give you plus 2 a squared b squared plus b to the 4. And so this happened to be a perfect square. So hypotenuse equal to square root of a squared plus b squared square. And the square and square root cancel out, so hypotenuse equal to a squared plus b squared. Okay, so this is a squared plus b squared. So once you do that, then it's easy, right? So sine of x would be sine of x would be equal to 2ab over a squared plus b squared. Okay, let's go to 192. Okay, a right-angled triangle ABC. So you have a right triangle ABC. Okay, so A, B, C is giving that F is the midpoint of the hypotenuse AB. So AB is the hypotenuse and this is the midpoint. Okay, and it says BC equal to 3AC. So BC equal to 3AC. So this is x and this is 3x. Okay, now let the point D and E divide the BC into 3 equal parts. Okay. Okay, so this is D, this is E, and it divide into 3 equal parts. Okay. forget about that one. So here's a point F, point E. Okay, so that's the picture we have. Okay. So this is right angled. And what are we looking for? Prove that DFE is isosceles right angled. DFE. So DFE is isosceles right angled. Okay, so you're looking for triangle DFE. Okay, so you have to kind of again remember the theorem. So if this is the right angle and this is the midpoint, so the midpoint of a hypotenuse of a right triangle is equal distance to 3 vertices. So so AF, BF, and CF are all congruent. Okay. And now if these are congruent, and by the way, so this is 3x, so divide into 3 equal parts, so it would be x, x, and x. Okay. And so you want to prove that DFE is isosceles. Okay. So what you want to do is you want to draw this straight down. Again, one of the tricks is draw parallel line. Okay. So draw this parallel to that. So this parallel line. So this would be congruent. Would be right angle congruent to that, right? So now use a similar triangle. Okay. So notice the hash mark. So this is half of that, right? So begin this hash mark. So this is half of that. So that means this would be equal to half of this. So this would be x over 2. Okay. And because when you okay, by just using the symmetry, okay, when you draw this thing straight down, okay, this will be the midpoint. So basically what you do is draw to the midpoint. So you have a triangle, you draw to the midpoint, okay, and because this is a right angle, so when you draw to the midpoint, it would be parallel. Okay, again, because this is the midpoint of these, therefore this would be midpoint of these when you're drawing the parallel. And if this is the midpoint, this would be x over 2. This would be x over 2. Okay, but now you have the same situation again. Okay, you have this point equal distance to 3 vertices. Okay, so that means this would be a right angle, and so this would be a right triangle, and this would be isosceles. Okay, so again, this becomes equal distance to 3 points. So this would be the midpoint of this right triangle. Okay, and because all these are x over 2, okay, so this would be also so this would be congruent triangles. So this would be equal to each other. Okay. So again, so this is a right angle right over here, and it's isosceles. Okay. The key is to draw this point right over here to get the M. Okay. So draw to the point M, the midpoint of these two, which is also midpoint of these two. Okay. And because this is the midpoint of this, and this is the midpoint of that, therefore these two will be parallel. And therefore you're going to get all similar triangle. And once you do that, if this is x and this would be half of that, so that's how you get x over 2. And because this is the midpoint and this is x, so you get x over 2, x over 2. So once you get all the x over 2 for all 3 parts, this becomes the midpoint of a hypotenuse, because this is equal distance to 3 points. So this is the center of the circle. Okay, so this has to be a right angle. So notice you use that theorem quite often, so that's a very important theorem. Okay. Okay, let's go to 193. Okay, so let's draw a big, nice triangle. Okay, and just call it A, B, C. And you have the one side is 10, so let's go and call this 10. So median to the 10 centimeter size. Okay, so median is the midpoint. let's call this M. Okay, so right away we can see that this is a 5, this is a 5. Okay, so what else we know? So a median to a 10 centimeter side of the triangle has a length of 9 and is perpendicular to a second median of the triangle. Okay, so it's perpendicular. I'm going to call this perpendicular. And find the exact value in the centimeter length of the third median. So what would be the length of the third median? Okay, so you're looking for this, the third median. You're looking for the length of this one right over here. Okay. Okay. So one thing you need to realize is that all three median will meet in one point, and median will divide this into ratio of 1 to 2. So if this is 9, this would be a 3, and this would be a 6. Okay. And if you notice, there's a right angle right over here. So if this is 3 and this is a right triangle, so this would be a 4. Okay. And again, if this is a 4, this would be a 2, right? Because this this point, the centroid, will divide this in ratio of 1 to 2, right? So you can divide into 1 to 2. Okay. Now, so now you have to figure out the other information. Okay. So you can use Pythagorean theorem. So this is 4, this is 6. So use Pythagorean theorem. So figure out the AC. I'm gonna call. Okay. So you got 4, 6, and AC. Okay. So divide by 2. So you got 2, 3, and this would be square root of 4 and 9 would be 13. So AC equal to 2 square root of 13. Okay. And once you do that, this would be square root of 13, and this would be square root of 13. Okay. Okay. Now, again, you have to use that theorem again. If this is a right triangle, the midpoint of the hypotenuse will equal distance to all three sides. I have 3 vertices. Okay. So this is the midpoint of this right triangle. Therefore, these 3 segments will be congruent. Okay. So if this is square root of 13, this will also be square root of 13, and this would be divide the ratio of 1 to 2, right? So this is square root of 13. This would be 2 square root of 13, and so this whole length, that's called BE. So BE will equal to 3 square root of 13. Okay. So again, 3 medians intersect at one point, the centroid point, and we divide the median into ratio of 1 to 2. So from the 9 we get 3 and 6. Okay, and the midpoint, this is the median, so this is a midpoint, and it is 5 because it's 10, right? So it'd be 5 and 5. And because this is a right triangle and you got 3 and 5, therefore this would be 4. You're going to get 3, 4, 5 right triangle. Okay, and once you get 4, you can get 2, right? And again, this is a right triangle. So you got 4 and 6, use the Pythagorean theorem, you get 2 square root of 13 for this side. And this is the midpoint, so you got half of that, so you get square root of 13, square root of 13. And because this is a right triangle, and this is the midpoint of the hypotenuse, so this would be equal distance to 3 vertices, so it would be square root of 13, square root of 13, square root of 13. Once you find square root of 13, again, ratio of 1 to 2, so it would be 2 square root of 13 for this part, so whole length would be, you add to, or you can just multiply this by 3, either way, so you get this answer. Okay. Okay, let's go to 194. Okay, a point is selected inside equilateral triangle. So just a random point over here. Okay, and so you got triangle A, B, C, and you're going to draw, and this point perpendiculars are dropped to each side. Okay, show that sum of the length of the perpendicular is equal to the altitude of the length. Okay, so I'm going to call this point P right over here, and this would be F, D, E. Okay, and because it is equilateral triangle, so you got AB equal to BC equal to AC. Okay, so what you need to do first is you want to go ahead and draw lots of triangles. Okay, so draw that. Whenever you deal with perpendicular, normally you have to deal with the area. Okay, okay. So let's look at the area of the small triangle of each of these. Okay, so K is so K equal to 1/2 AB times, so 1/2 base times this height, so it'd be PF. Okay, so that's area of this triangle. So the area of the whole triangle is equal to the three triangles. So this plus that. Okay, so first one is this area. So second, so you're going to add 1/2 BC times PD. Okay, plus 1/2 base times the height. Okay, so you can 1/2 base times height for this one, 1/2 base times height for this one, 1/2 base times 3. So that's the whole area equal to the sum of the three triangles. Okay, so K equal to 1/2. And since they are all equal, you can substitute, right? Okay, and you can factor out. So you can factor out the half, and you can factor out the BC, because they're all equal. So this equal to BC, this equal to BC, BC, right? So you can factor it out, and so you end up with PF plus PD plus PE. Okay. Okay, and you also can think of this. You can also draw the altitude. Okay, so draw the altitude over here. And this is from the A, so I'm going to call this H of A. Okay. So the area, if you do the whole thing by itself, will equal to 1/2 the base times the height, right? So you can figure out two ways. By figure out you adding the area of the three small triangles together, or you can figure out directly, right? 1/2 base times height. So that's what that is. Okay. And so now you can see the 1/2 BC cancel out, right? So you got PF plus PD plus PE equal to the HA. Okay, so sum of the three perpendicular segments equal to sum of the altitude. Okay, and that's it. Okay, let's go to 195. Okay, 195, the picture is given, and it's an equilateral triangle. Okay, so this is A, B, C, and you have, this is not very good. Okay, the M over here, and you have the midpoint, and you have all these points over here, and you have the P right over here. So this is K, S, N, Okay, so this is this picture over here. And you want to prove that angle MNB equal to 90 and angle KPN equal to 90 degrees. Okay. So since this is equilateral triangle, we know that this is 60 degrees, and this to the midpoint. So, and because it's equilateral triangle, so this would be by you cut in half. So this would be also 30 degrees. So what we're going to do is, since it's divided into 4 equal parts, I'm going to call this 4x. So this would be a 2x, this would be a 2x, and this would be x over here. Okay. Again, the key to this problem is to draw the midpoint to here. Okay. So call this point Q, and you draw this midpoint over here. Since this is 2x, and you draw the midpoint, so this would be x and x. Okay. So just like the problem that we did earlier, so you have two congruent sides, so this would be two congruent angles, okay? And this is 60, so these two have to equal to 120, and they have to be congruent, therefore this would be 60, okay? And therefore all this would be x, okay? Now, again, you got x and x over here, so these are isosceles triangles, okay? And this is 60, so this would be 120, and therefore this would be a 30 and 30. Right? Okay. And also, and so this is the 90 degrees right over here. And so now you have 30, 60 spatial triangle. So if this is x, this would be square root of 3x. Okay. And this is 2x over here. So therefore, this would be 2 square root of 3x. And this half of that, this would be square root of 3x. So using a lot of spatial triangle, right? I mean 30. And so, and if you look over here, so this is square root of 3, this is square root of 3, so this would be isosceles. Also from here, 30, this would be 60. And so you have same situation over here. So this would be also an equilateral triangle. It would be square root of 3x, so it would be 60 degrees, 60 degrees. Okay? And so, okay, so what else do we have? Okay, so we're looking for M, N, B, so we did that, right? So we proved that, so this is checked. So right now you need to look for K, P, N. Okay, so you're looking for these over here. Okay. So what you need, since this is the midpoint, again, you draw the parallel line to this, right? So this is the midpoint of this is the midpoint of that, therefore this and this are parallel, and the ratio is 1 to 2. Since this is 2x, this would be an x. Okay? And notice now, this is x, this is x, this is x. Therefore, this is the equal distance to 3 sides. Therefore, this has to be a right angle, and this is the center of the circle. So you can remember the theorem we did, and that will take care of K, P, N. Okay. Okay, let's go to 196. Okay, so you have a triangle ABC. If angle is greater than B, then BC greater than AC. Okay, so let's consider two situations. Okay, let's consider if it's a obtuse angle. So, okay, so you got A, B, C. So you have this kind of situation. So let's call this A, B, C. So in this case, what you need to do is you need to go and draw the altitude down. Okay, and call this D. So this is H, this is X. So apply the Pythagorean Theorem using this triangle over here. So B squared equal to H squared plus X squared. And now you use this whole big triangle. So A squared equal to H squared plus X plus C squared. Okay. And since this is greater than that, okay, so you can minus the H squared on both sides. So since this is greater than that, so again X plus C squared is greater than X squared. So therefore A squared had to be greater than B squared, and A had to be greater than B. Okay. So again, if this is bigger than this, okay, if this is more than that, then this would be bigger than this. right? Because they are equal, right? And take the square root. Okay, now let's look at a second situation. If A is acute angle, okay. So if it's acute angle, again, you just drop the altitude and call it h. And then, again, figure out the h. So h equal to b sine angle A from this triangle. From this triangle, h equal to A sine of B. Okay. And again, now they are inverse, right? So if angle A is greater than angle B, okay, so if A is bigger, then sine A would be bigger than sine B. Okay. So and because of h, so you got A sine B is equal to B sine A, because both are equal to h, right? So you said that. So if this is bigger, okay, so if this is bigger, then this has to be smaller to even it out, because they're equal, right? So again, if the sine A is bigger, then you're going to get A is greater than B, okay? And so that's it.